Good morning. In this video, I'm going to discuss compressors. So compressors are devices that increases the pressure of gases. Let me share the PowerPoint. Okay, so probably you have seen one when you increase the pressure of the tires. So there are two general types, the reciprocating piston or the piston type. This is usually, the first type is usually used to increase at a relatively high pressure. The more common type is the rotating blade. So let's take a look at these two types of compressors. So as you can see, the reciprocating pistons contains piston assembly. You have the cylinder and the piston. So the piston, when the piston compresses the gas, so the gas pressure increases, and then the bulb, when the wanted pressure is reached, the bulb open. No, so most probably you have taken momentum transfer. Na-discuss din naman to sa momentum transfer. Ano? And then the second type is the rotating blade. So generally, a rotating blade piston, the rotating blade increases the velocity of the gas. So the increased velocity results to an increased pressure on the other end of the compressor. Okay, so according to Banes, as chemical engineer, our duty is not really to design such device. So like compressors. So no, our duty is to specify the energy requirement. So basically, kina-calculate lang natin ay yung horsepower. And pwede rin siguro yung type, pwede natin i-specify. So sa momentum transfer, pinoint out ko na sa inyo kung nasa inyong diagram na ginagamit sa pag-determine ng type ng compressor na ginagamit. Okay, so kung tandaan niyo pa, aside from compressor, meron pa tayong mga blower, saka mga fan, no? So, okay, compressor efficiency. So, pag in-imagine nyo, this is a electrical device. So gumagamit siya ng kuryente para umandar, ano? So pag mas mataas yung kanyang efficiency, generally, relatively mas mababa o mas konti yung kuryente ginagamit niya as opposed to sa pag mas mababa, no? So yung ideal dito, yung pinakamababang makukonsume na electricity, no? O yung pinakamababa yung power. So yung efficiency equation natin is Ws isentropic divided by the actual, or Ws ideal divided by the actual. Compressor efficiency are usually in the range of 0.7 to 0.8. Kamukha din na sa turbine. So ganun din sa Aspen High-Seas, ang default value yun ay 0.75. So if we're going to take a look at the diagram here, we have the entropy on the x-axis and the enthalpy on the y-axis, and we have the constant pressure curve or the isobaric curve. So if we have an isentropic process, no, constant S from 0.1 to 0.2 prime. So take note that you're going to, it will result to a smaller delta HS, no, relative to the actual delta H, no? So mas konti yung makukonsume niyang kuryente, syempre kung isentropic yung process. Okay, so pero syempre, second law of thermodynamics, the entropy of the universe is increasing. So if the entropy increases, as you can see, mas mataas yung actual delta H. So that's why the efficiency is, equation ng efficiency is delta HS, the ideal delta H divided by the actual delta H. So dapat kasi yung efficiency natin, yung compressor efficiency ay less than 1. Siyempre. Okay. So basically, ganun din yung equation nito. Ano, yung kamukha nung sa turbine. Wala rin naman siyang potential energy. No? Pakita naman kayo ng compressor, hindi naman masyadong tumataas. Yung kanyang elevation, hindi naman masyadong bumababa. Tapos generally, yung kinetic energy dyan, negligible din naman. Tapos pag isentropic, yung process, yung Q, zero din naman. So, yung matitira na lang dyan, yung shop work at saka yung delta H. So, shop work is equals to delta H. So, kamukha din yung kaya sa turbine. So, pag multiply nyo yung both sides ng M dot, yung WS magiging WS dot. That's the compressor power, yung horsepower niya. Tapos equal din lamang yun sa M dot times delta H. So in the case of the compressor, syempre, usually ang kinocompress natin, mga air or different other gases, hindi syempre tayo gagamit dito ng steam table. Ano? Tayo gagamit ng steam table. Ang isosolve natin problem dito yung sa air. No? So, pag yung air yung case, ang gagamitin nating equation to solve for delta H ay yung Cp delta T lang. Okay? Cp delta T. Delta H is equal to Cp delta T. So, generally, pag may compressor problem, okay? So, di ba, it's basically WS. Basically, ganun din naman yun. WS is equals to delta H. And then delta H is basically Cp delta T. No? And then to find the final temperature, usually kasi pag may problem sa compressor, usually ang given yung initial pressure at saka yung initial temperature at saka yung final pressure. So to find the final temperature, we usually use the adiabatic equations. No? So usually pressure yung given, so usually ito yung ginagamit natin. You can find this on Perry page 10-44. Ano? Okay, mark yung page na yun. Kung sakaling makalimutan nyo itong P2 over P1 is equals to P2 over T1 K over K minus 1. And then remember, dapat yung temperature dito ay absolute temperature. Pwedeng Kelvin, pwedeng runtime. So, ganun lang. Ano? That's how simple to solve the compressor horsepower. Okay, so let's try to solve problem 7.35. A compressor operates adiabatically with air entering at T1 and P1. So T1 is 25 degrees Celsius. Ano? Ito yung initial temperature natin. Ito yung initial pressure natin. With the molar flow of N dot, so 100 mole per second. The discharge pressure is P2. So P2 is 375 kilopascal. And then the compressor efficiency is 0.75. So we need to estimate the power requirement of the compressor. So pwedeng kilowatts, pwedeng horsepower. So basically, gagamitin lang natin yung adiabatic equation in terms of temperature and pressure to find T2. Tapos pag may T2 na, Cp delta T lang. Ano? Sunod, after the power requirement, temperature of the discharge. So to find the temperature, pag alam natin yung actual delta H after using the efficiency, we can equate that to Cp delta T. Then we can solve the final temperature. No? So actually, ang kalimitang mali dito, hindi ko alam kung nagmamadali or tinatamad na. Ang usually ginagawa kasi nila, kung ano yung lumabas dun sa adiabatic equation, yun na rin yung nilalagay nilang temperature ng discharge. Which is mali. Ano yun? Ideal yun. Siyempre, alam niyo naman, in the real world, hindi mangyayari yung ideal. Hindi isentropic yung process. Nag-i-increase yung entropy. So, dapat, i-resolve yung temperature in terms of the actual delta H. Ano? Okay, so probably I'm going to share a whiteboard para mas maayos yung solution natin. Okay, so we have a compressor. Actually, ang compressor, ikabaliktaran lang ng turbine yung kanyang symbol. Ano? Kaliit lang siya. So sabi sa problem, T1 is 25 degrees Celsius. Tapos T1 is 1 atmosphere, ano? 101.33 kPa. Tapos what we have is P2. P2 is 375 kPa. So first, we assume that the process is adiabatic and reversible. Ano? So we can use the adiabatic equation for temperature and pressure. So that is T2 divided by T1 is equals to, sorry, it should be P2 divided by T1 is equals to T2 divided by T1 tapos raised to K over K minus 1. Okay, if you still remember, K is Cp divided by Cb. Tapos, Cp is Cp for air. This is air. This is air. Cp for air, you still remember, kasi diatomic sila, is 7.5 R. Kailangan tandaan yan. Ano? So, Cb is minus R. So, this is 5.5 R. Magka-cancel lang to. Yung magka-cancel. So, K is 7 over 5. Tapos, calculate na natin tong K over K minus 1. So, K divided by K minus 1. This is 7 over 5 divided by 7 over 5 minus 1. This will give us 7 over 5 all over 2 over 5. Cancel itong dalawa. We have 7 over 2. Tapos substitute lang natin dito yung mga given. Ano? P2 is 375 kPa. Tapos P1 is 101.33. Tapos P2 is, yun yung hinanap natin, unknown na. Tapos we need to convert 25 degrees Celsius to either Kelvin or Rankine. So, syempre sa Kelvin tayo, no? 25 degrees Celsius plus 273.15 is 298. Tapos, erase nyo lang siya sa 7. So from this, should be able to come up with T2 is equals to 433.32 Kelvin. No? Tapos, you know, we can now calculate the horsepower or the power of the. Basically, we can use the efficiency equation. So, the efficiency equation is yung delta H. Ang tanong kasi ilan yung horsepower, di ba? Ilan yung horsepower. So, delta H, ito yung ideal, ito yung delta HS isentropic divided by yung actual. So, itong 433.32, dito yung sa delta HS. Ano? So, ang given na efficiency ng turbine ay 0.75. So, 0.75 tong N. Okay. So, i-multiply na natin ng N dot, para power na talaga. Power na talaga yung lalabas dito. Times N dot na yun. So, parang ito na talaga yung, ito, equal na to sa WS dot. I hope you can follow this. So, itong n dot is 100 mole per second. Tapos yung delta H natin is 7 hubs. Tapos times 8.314. Remember, this 8.314 is joules per mole per second. So, magkakancel dito yung mole. Diba? Sorry, this is joules per mole per Kelvin. Tapos yung Kelvin natin, yung delta T. So, ang delta T natin ito, 33.32. Minus yung initial temperature natin. Initial temperature natin is 200. So, joules per mole per Kelvin, magka-cancel out yung mole, tapos yung Kelvin magka-cancel out sa unit na to. Tapos joules per second na lang to, ano? So, parang watts yung lalabas dito. So, ito yung WS. Ito yung power, no? So, you're supposed to get something like 524,000 yung WS data, no? 524,442 watts. Okay, so this is approximately, in kilowatts, this is approximately 524 kilowatts. Pag kinonvert to, isang pindot lang naman sa calculator, ano? So divided by 5.7457 sa calculator, this is the conversion factor. This is also equal to approximately 703 horsepower. Ganun lang kadali. No? Now, what about the final temperature? So yung final temperature naman, equate natin dito sa 524,442 yung CP tsaka itong 100 mole per second, no? Sans the efficiency na 0.75, so parang equate lang natin yung 100 times 7/2 tapos times 8.314, okay? Tapos times delta T. So, makukuha nyo yung delta T dyan ay 524,442 alpha equal 100 times 7 divided by 2 times 8.314 delta X. Yun, 180, ano? So, since delta T is 180, siyempre pag kinompress yan, idadagdag nyo lamang ito sa initial temperature na 25. So, 180, so ang final temperature is 180 plus 25 plus 273 para maging Kelvin. Ano? So, this is 478. Ano? 478 Kelvin. Okay? So take note, iba to, kaysa dun sa initial temperature na na-calculate natin. Ito yung ideal. Pag ideal yung process, which is hindi naman talaga nang nangyayari yan sa totoong buhay. Yung nangyayari sa reality. Ito talaga yung actual temperature. This is the actual temperature. Ito yung tinatanong. Okay? So, ganyan lang kadali lang. Ganyan lang naman kadali. Ano, ay na-discuss na rin naman natin yung sa momentum transfer. So, I hope natatandaan niyo pa. Okay. So, see you on the next video. Bye-bye.